really challenging part of the mission, which is orbiting in the low gravity environment of the asteroid. Over the past few months, the Flight Dynamics team has been getting images of the asteroid Bennu, and it started out as just a very small point source in the camera, and it's been getting bigger and bigger and bigger in the field of view. And that's allowed us to perform optical navigation to refine our prediction of the asteroid's orbit and allow us to more precisely navigate and target our approach to the asteroid.
As OSIRIS-REx approaches the asteroid, we've done a series of braking maneuvers called asteroid approach maneuvers to slow down the spacecraft so that we can get into orbit around the asteroid later this year. We're also taking lots of images of Bennu to understand its rotation, look for natural satellites, and potential dust plumes.
This is an extremely exciting time on OSIRIS-REx as we're just poised at arrival at Bennu. And one of the most exciting things to us, and relieving too to the engineers, is how closely the asteroid has resembled what we had predicted. Early on, our science team, prior to launch, had come up with a model of what they thought the asteroid would look like based purely on ground-based radar observations from Arecibo. And from that, they created a reference asteroid that we used as the requirements to design the mission against. But no one could be sure that the asteroid would really look like the scientists had predicted. So it's been a tremendous relief to us to find that the actual Bennu is very similar to what the scientists had predicted. So the science team really nailed it.
Well, right now, as we're approaching asteroid Bennu, we're looking for debris or other objects that are orbiting the asteroid, just in case we need to avoid those. And then once we arrive on December 3rd, we'll perform preliminary survey. And in preliminary survey, we fly over the North Pole, South Pole, and the middle of the asteroid. This helps us to map the gravity of the asteroid and understand how to operate near such a small body. Additionally, this will be the first time that we get close-up pictures of the surface, and we'll know how smooth or rocky the surface that we're going to study is.
As we get closer to asteroid Bennu, we'll begin to map its surface in higher detail. What we'll be able to do is first identify the distribution of rocks and particles that might pose a hazard to the sampling mechanism on the spacecraft. And we'll also get a better sense of what the shape of Bennu is like at smaller scales. Looking at Bennu in more and more detail is going to help us identify all the areas that we shouldn't go to grab a sample from.
Throughout 2019, we'll be doing global characterization of the asteroid, basically making maps of the entire surface. We're interested in its topography. Are there craters? Where are the boulders, the valleys, the mountains of the asteroid? And then we want to understand the distribution of geologic materials. Are we finding different patches of minerals in one location versus another? And why are certain areas have a composition and others may be different? We're going to be looking, most importantly, for areas where we can collect a sample.
OSIRIS-REx will collect a sample from Bennu using our TAG-SAM, which is the Touch and Go Sample Acquisition Mechanism. What that is an arm connected to this sampler head that
How do you assemble the largest rocket ever made? With very, very large cranes. The Space Launch System, or SLS, will be the most powerful rocket we've ever built. The fueled-up core stage weighs around 2.3 million pounds and measures 212 feet long. That's taller than the Leaning Tower of Pisa. We're getting ready for the countdown to send SLS into space. We have only one shot to get everything stacked up right. Here we are in High Bay 3 of the Vehicle Assembly Building. This is where the magic happens. Our crane operators are specially trained to handle loads as enormously important as SLS. Some even helped assemble the original space shuttle. We need to make sure our people and our equipment are safe during this huge lift. That's why we use digital simulations to practice lifting the fuel tank and assembling the solid rocket booster. Then we will use a replica of the tank to practice the lift before the real deal. Our crane operators perch at the very top of the high bay to coordinate the lift, so you better not be scared of heights. During every step of the process, the lifting crew will constantly be using radios to check in. and quickly stop the lift in case of emergency.
And as you can see, it's going to be a huge rocket with a lot of huge lifts.
When the dress rehearsal is over, it will finally be time to start.
Traveling at a velocity of 2,000 meters per second.
Our InSight mission arrives at Mars, announcing the companies that will help us get to the moon, and the space station's next crew wraps up pre-launch activities. A few of the stories to tell you about this week at NASA.
Touchdown confirmed.
That confirmation at 11:52 a.m. Pacific Standard Time on November 26